Hello and welcome to my Physics 2 Lab projectile motion. Okay, here's the introduction, purpose and procedure. Purpose is to show projectile motion of an object when thrown and display Newton's second law. Procedure is placing a measuring stick on a flat surface and tossing a scrunchie in an arc. Uploading the video to Tracker for analysis and creating both X and Y position time graphs from the tracker. Using GlowScript data to create an ideal computational model of both position time and velocity time graphs. And comparing and analyzing both the tracker and GlowScript data and explaining potential experimental flaws that could contribute to their differences, as well as comparing X and Y trajectory. Okay, and to the right we have the relevant equations. The one at the bottom is not quite correct. I have corrected that to the left at the bottom. And today we are applying Newton's second law. Acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The consequence of this is that the net force should in the y direction give no drag. The x velocity should be constant. With drag, the x velocity will no longer be constant and the y velocity will be negatively affected as you no longer have just the force of weight acting upon it, but the force of drag acting in the opposite direction. Drag can be calculated using the equation at the bottom right. Okay, and here is my tracker data. A system is the scrunchie and the surroundings are the classroom. Tracker is not factoring in drag, so the x position time graph is a straight line as the velocity is constant. The y position time graph is a parabola as the object is being thrown in an arc and net force equal to its weight is acting upon the object. Okay, and here are my graphs up close. Again, as you can see, the position versus time for x is linear as there is no net force acting upon it. And the position versus time for y is a parabola because you do have a net force acting upon it, which means that the velocity is not constant. Okay, and then here are the other graphs for GlowScript. Here is my code showing how I found the position of the ball as well as the velocity, and this is with no drag. And then here's my GlowScript code with drag. And my results are pretty similar with drag. I don't think drag affects it that much. It's a pretty small force acting upon a larger system. So these lines do have a slight curve to them, but it's a little bit hard to tell just from the position time graph. It's easier to tell from the data itself. Okay, and this is just a slide saying what I've already said before. Okay, and here's my tracker versus GlowScript data. As you can see, the green is tracker, the sort of blue-green is tracker, the green-green is GlowScript model, and the blue is GlowScript model including drag. And the results are that both tracker and GlowScript show pretty similar results. The difference may be due to the clip in the video I used being kind of blurry. Also, again, it was a pretty small time frame, so there could be something off with that. And the drag made the position change more slowly in the y direction as it applies a force opposite of that to weight. Okay, and here are my final thoughts. What if the object was not thrown in an arc? It would experience acceleration in the y direction, but none in the x direction. And what does this mean? Since the object is not at terminal velocity, it will have a net force acting in the y direction, making its velocity in the y direction no longer constant. And some of the possible errors, as I mentioned before, is the video was not really clear, and the scrunchie may not have been thrown in an even arc, making our ideal model not as accurate. Okay, and that'll be all today. Thank you for watching.